Okay, so in this video we're looking at tree diagrams, which we looked at the grade 5 level, but when it comes to grade 6 level, it's now tree diagrams with conditional probability, right? Which just means, so conditional probability is when the probability of an event is dependent on the outcome of a previous event. What does that really mean? It just means that the probability is going to change. It doesn't remain fixed. So for example, just to give you the really basic idea here, let's say we've got a bag of apples and oranges. So we've got a bag of, let's say 1, 2, 3, 4. These red things here are apples, okay? And then let's go and put some oranges, for example. Let's go and make those yellow. So 1, 2, 3 oranges. Right, let's go and say, literally, right, imagine me taking a pick from this bag here of apples and oranges, the ones in yellow. Right, if on my first pick, I want to, well, if I ask myself, what is the probability of choosing a red apple on the first pick? Well, it's going to be 1, 2, 3, 4. It's going to be 4 out of a total of 1, 2, 3, 4, 5, 6, 7. Okay, so the probability, so I could write it, the probability of picking a apple, okay, on the first pick is 4 out of 7. Okay, and with conditional probability, right, we then say, well, if I literally go and remove, I've taken one of the apples here, so one of them is now gone. Okay, if I take a second pick, what is the probability now of choosing an apple? Well, it's going to be 1, 2, 3, not 4. Okay, because I've literally removed one of the apples, I've taken it out of the bag. So I would now say the probability of getting the apple on my second pick is going to be 1, 2, 3. So 3 out of a total of now 6. I've reduced it by 1. Right, so conditional probability is where the probability of your events is going to change, which is different to at the grade 5 level where the probabilities remain fixed. So that's a really important point to note. So let's get into a question. We'll look at 2 examples and that will be it for this video. Okay, but it is tree diagrams, which hopefully we are pretty familiar with in class, but also at the grade 5 level. So we'll go through this in real detail, and then you probably kind of recognize you don't always need to draw out the tree diagrams and everything, but you'll kind of pick this up. Maybe you'll pick up things yourself, which would be really good. Okay, example 1. Right, inside a bag, there are 4 apples and 3 oranges, which we can see over here. And James picks 2 items out of the bag without replacement, and that's a really, really important part of this question, right? Without replacement means he literally will take a bit of fruit and he doesn't replace it. So what is the probability he chooses 2 apples? Well, let's go and draw up a tree diagram. So he does two picks, so we can go and say, right, on the first pick, and let's go and draw a little tree out, so here and then here. Well, let's go and say for this branch up here, we're going to say the probability of choosing an apple on the first pick is going to be, well, there's 1, 2, 3, 4. So there's 4 out of a total of 7 items. Okay, there's 7 bits of fruit in total, right? Which must mean that the probability of choosing a orange is equal to, well, it must be 3 out of 7. And we can see that visually, right? There are literally 1, 2, 3 oranges, which is really important. Okay, so note, I could have put oranges on the top and apples on the bottom, but it makes no difference. But I've got to stay consistent now with having apples on the top, oranges on the bottom. And also note, right, 4 over 7 and 3 over 7 makes 1. Every part of your tree must sum, add up to make 1. Okay, that's the first pick. But then he chooses 2 pieces of fruit, so then we have to go to a next part of our tree, and we go and write our second pick for James. Okay, so let's go on to this one. So we're saying, right, if James, right, picks a apple on his first pick, so let's go and highlight this. If he go and chooses an apple on his first pick, because we're looking at the apple part here, well, that must mean, right, then he's taken the apple and it is now gone. So we've removed that apple. So on the second pick, because if he's taken the apple and not replaced it, there's now only 1, 2, 3 apples. So the probability now of choosing an apple, right, is going to be 3 out of not 7, but 6, because there's only 1, 2, 3, 4, 5, 6 pieces of fruit left. Okay, and then there's still 3 oranges, 1, 2, 3. So there is still only 3 oranges, but the probability now of choosing an orange, right, is just going to be 3 out of 6. There is only 6 bits of fruit left. So we're saying, right, if on the first pick he chooses an apple first, well, the apples must reduce by 1 to 3. Okay, but there's still 3 oranges, but the total is reduced by 1 to go to 6. So there we go. That's what's going on there. Okay, oops, didn't mean to do that. Let's go to these highlighter bits. There we go, there we go, there we go, there we go. Okay, similarly, right, James could also pick an orange on his first pick. Okay, so then we're going down this route down here. We could go orange first, which then means on the second pick, right, and I've got to keep it apples on the top. That's what I've been going with. So probability of choosing an apple. Well, if James on his first pick chooses an orange, right, so literally he chooses an orange, right, on the second pick, there's still going to be 1, 2, 3, 4 apples. So it's going to be 4 apples out of a total of 1, 2, 3, 4, 5, 6. There is now only 6 pieces of fruit, but there's still 4 apples, right? But if he chooses an orange, okay, that must now mean that the probability of choosing an orange on the second pick, well, he's chosen one and not replaced it, got rid of it. There's now only 2 oranges left. So it's going to be 2 here out of, getting a bit cramped, sorry, out of 6. Okay, 6 pieces of fruit left. Oh, that's very cramped, isn't it? Let's write it. 2 out of 6. Okay, so again, really key points. I've got apple, orange, apple, orange, apple, orange. I'm not changing up the order of that. That's really important. And the question is saying, right, what is the question actually asking for? It is saying, what is the probability he chooses 2 apples? So we're looking at choosing an apple, which is here, and choosing an apple, which is here. So really for this question here, maybe you just spotted, well, the probability of choosing an apple is going to be 4 out of 7. If you choose an apple, right, there's only going to be 3 left out of 6. So maybe you recognise that, but it's good to go through the whole thing just so you can see what is going on. Okay. So probability to choose 2 apples is going to be 4 over 7, and you've got to times it by your second probability, 3 over 6. So we can say probability of getting an apple and then an apple is going to be 4 over 7 times by 3 over 6. Okay, and the timesing fractions, we're doing 4 times 3, which is 12, 7 times 6, which is 42. Right, and with probability, you don't need to simplify. It is the one topic at the GCSE maths, where you can leave your probability, your fractions, unsimplified, and that is absolutely fine. Okay, so that there is our answer as a fraction, which is good. The probability he chooses 2 apples is 12 out of 42. Okay, where it's more useful to draw out the whole diagram is if it might say, like on the next question, example 2, right, we've got the probability that at least one of the picks is red. So we'll read the question, but you'll see why a tree diagram here is probably a bit more useful. So we've got a bag contains 5 red balls and 3 blue balls. If you want to, you can try this one yourself, pause the video, and then you can fast forward to the end, or you can work through it with me. Either way is good. Right, 2 balls are taken out and then not replaced. What is the probability that at least one of them is red? So again, right, we're taking out 2 of these balls, and then they are not being replaced, right? Which means we're looking at conditional probability, right? Because the probabilities are going to be changing if you don't replace it. Okay, so let's do the first pick again. Let's go make this nice and clear. So we've got our first pick up here. And let's go and say, well, the probability of choosing a red ball is going to be, well, there's 1, 2, 3, 4, 5. There's 5 reds out of a total of 8. And the probability of choosing a blue, well, it must be 3. We can see there's 3 left. So 3 out of a total of 8. So we're saying, right, if on the first pick, we go and take a red, so on the first pick, we take a red, so literally one of those reds is being removed, well, that must then mean, right, on the second pick, let's go make that nice and clear, on the second pick, well, the probability of choosing a red, right, is now gone down by 1, because I've taken this one out and not replaced it. I've now got 1, 2, 3, 4 reds left, so 4 out of a total of 1, 2, 3, 4, 5, 6, 7, so 4 out of 7. Okay, and the probability of choosing a blue, well, there's still 3 blues left, okay, but the total is still out of 7 because I've reduced the red by 1, so 3 out of 7. Or I could go and choose a blue ball first, so not a red. I could choose a blue, right, and not replace it. So if I go down this branch, the probability of choosing a red, well, there's still 4 reds in total. Sorry, 5, 1, 2, 3, 4, 5. So 5 out of, but this time the total has gone down by 1, so 7 again. And then the probability of choosing a blue, well, blue has gone down by 1. I've now only got 2 blues left over, so 2 out of a total of 7. Note, I've got red, blue, red, blue, red, blue. I'm not changing how I've written things, okay? And also 4 out of 7, 3 out of 7 make 1, 5 out of 7, 2 out of 7, they also add up to make 1. Okay, the question is saying, what's the probability that at least one of the picks or one of the balls picked is red? So at least one could mean that we've got both being red, so red and then red. That's at least one red, because at least one means it could be both, or it could be a red and then a blue. That is still at least one red, or it could be a blue and then a red. That is at least one red, blue and then red. I can't go blue, blue, of course, because that is nothing being red. So now I've got to go and work out the probability of each part. So red and then red. Let's go and write it here. So red and then red, which is going to be equal to 5/8 timesing through by 4/7, which is equal to 5 times 4 is 20. 8 times 7 is 56. Okay, so that's probability getting 2 reds. Or I could get a red and then a blue. So a red and then a blue. Where I've got probability is 5/8 times by 3/7. So 5/8 timesing through by 3/7. 5 times 3 is 15. Over 8 times 7 is 56. And this is why it's a really good idea with probability not to simplify your fractions, because you'll see at the end, we've got to add everything up together. And if you start changing the denominators, it gets a bit trickier. So leave it in unsimplified form. It's going to make things a little bit easier. Last one, we're looking at getting a blue and then a red. So we're going blue and then a red, where the probability is 3/8, so 3/8, and we're timesing through by 5/7. So 3 times 5 is 15, 8 times 7 is again 56, okay? To work out the probability that at least one of them is red, you just go and add up your 3 options together. So we're going to sum those together. So adding fractions, you add the tops together if they've got the same denominator, which they do. They're all out of 56, so we're doing 20, add 15 is 35, add 15 is 50. Okay, so our total is going to be 50 out of 56. Okay, and that there is our answer. Okay, good. Okay, if you got that and you did it on your own, that's fantastic. But hopefully that was useful on conditional probability. Thank you.